myself. Hey everybody, I'm Haven King. I am an engineer at Orkes, short for orchestration. It is a weird, difficult name to pronounce, so I forgive any mispronunciations. Today we're going to be talking about scaling and managing complex agentic workflows. Lots of stuff going into this here title, but hopefully it'll be clearer what we mean by agentic workflows in particular, by the end of this presentation, and there is some non-presentation, not just slides content afterwards as well. So first, what is an AI agent? Well, what is an agent? An agent is something that can make decisions. It has agency, right? AI agents are really popular these days because AI has become all the rage. Prior to that, we had human agents, right? When somebody is looking at an application or making any kind of decision, they're an agent. You have a real estate agent or an insurance agent, right? AI agents are just taking those processes that we were already doing as humans and making it so that we can do them in an automated fashion. So what is an agentic workflow? Well, a workflow is the process, right? It's something your business does. It's something you need to do as a company. And an agentic workflow is a process that can run with agency, a process that can run on its own, right? It can make its own decisions. It might be an agentic workflow in the traditional sense with a human making the decisions, right? That's part of the workflow. It's still going to be part of that process. It decides what to do. Or in today's day and age, what we're going to be talking about largely today, it might be an AI making that decision. Could be Google's, could be Microsoft's, could be AWS, right? Wherever you are, there is an AI today that you can probably use, and you can use that within your workflows to make decisions for your business. So here we have just a little bit of a diagram. This isn't going to be a super architecture-y diagram, but it is showing you some various components of your system that are interacting with one another, both in the context of workflows, in the context of agentic workflows, but even just in the context of your business, right? So if we look at the right here, you'll notice some things that are going to be familiar to anyone who's built a large-scale system. You have some memory, right? Short-term, long-term, working memory. These are going to be things like your in-memory cache, your Redises for short-term. Your long-term might be like a long-lived business database, right? Something like a Postgres or even something a little bit more durable than that. And then working memory is likely the actual instances, the actual things you are running, your programs, right? That's your working memory. Any business process is going to have probably all three of these different kinds of memories, and those are going to extend to your artificial intelligence infused workflows as well, right? They're going to need to have a conversation. If we're talking about like a chat bot, it's going to have that working memory is for that particular chat process, right? Versus long-term memory is going to be something like the entire record of what your company has ever done so that they can contextually provide information to your users. Short-term memory and working memory in the context of a chatbot are kind of fuzzy, but point is you'll have everything here. You'll have all of these things. You'll have the core engine for actually making the decisions. You'll have the tools and systems that exist in your enterprise today to work with. And an agentic workflow is going to allow you to take all of these disparate systems and connect them to one another in a way that helps your customers without needing to have humans come in and do these expensive decision processes. So scaling agentic workflows, kind of in the title of this presentation, and something that can be very difficult, particularly for very large enterprises, larger organizations. You might notice this slide has nothing to do with AI in particular. That's because, as I've said a few times now, agents have historically been humans. And these are all largely organizational challenges, right? Complex interactions, the number of agents in an organization grow. Within an organization, within different sub-organizations, right? You have different departments at your company. They have to be able to communicate with one another effectively. They have to be able to figure out why processes aren't going the way they are supposed to. That's debugging and monitoring. Now we're taking a bunch of human-oriented problems and turning them into technical problems because we can solve those more systematically. I'm not going to read all the bullet points. Surely you've had time to by now, but these are all just examples of problems that apply to humans and apply to AI agents. And we can solve them by building these and modeling these processes out as workflows, right? So now we've talked about agents a little, we've talked about workflows a little, and what these different systems are going to look like. And so you need a base foundation to actually run these workflows on, right? What we're talking about here, and what Orkes, right, my company, kind of offers, is a runtime that can be used, a workflow runtime that can be used to run and manage these agentic workflows. Taking a step back for a second, Orkes is not purely a agentic workflow tool. It is a more abstract workflow tool. We do have agentic workflow functionality built in for a lot of these things, but that's what gives you the power to use this kind of platform and expose the same functionality to your AI agents that you might to some of your developers or to some of your human workers that you have in the loop today, right? We give you some functionality such as allowing you to have some aspects of your workflow within the development, right, within your engineer's purview, and some of it being determined at runtime. You might choose to go down one branch one way or another based on input or decisions that are made ahead of time or during execution. Additionally, we're going to allow you to, in one place, centralize what all of your agents are doing and what they can do. Governance of agents can be applied to both humans and your AI agents, right? You can use similar models of control to define what different people, or in this case, AI agents can do and can access, both from a data perspective and an action perspective, right? Things that they can do on behalf of you and your business. Model and prompt governance is going to allow you to define ahead of time what these prompts and what these agents are going to be able to do on a more like textual basis than just access and control. Like you can define the exact action that the agent can take. And that one sounds a little abstract until I get into the later portion where I'll be actually showing you some of these concepts in action, right? Role-based access model kind of plays into centralized governance of agents. Auditing model responses is super useful, and again, it is useful in the scope of AI models, AI agents, because so much of what we are doing is input, output, and a workflow orchestration tool really is going to help you centralize where that input and output lives so that you can audit over time the different evolutions, the different processes that are running within your environment. Visibility into decision making, right? We talked on a previous slide about observability. You get to see where things are going, who's doing what. And finally, scaling as the workload increases. This is somewhat an AI problem, really just a system problem, right? How do you build good, scalable, distributed applications? Orkes Conductor is an example of an application where we built that in mind, right? So you're able to scale your application to meet your needs without having to worry about it on your business side. Cool. Here we just kind of run through a lot of what I was talking about previously. Task orchestration, you'll notice on the right, we have a pretty diagram. This is our workflow diagram, and you can see at various points, we are making decisions within that workflow, right? We are going down path A or B or C. This is orchestrating those various tasks, some of which might be AI related, some of which might just be boring old SQL queries to your database, right? But they're things that need to be done and decisions that need to be made with respect to one another. Not shown in this diagram, but equally as important as choosing what to do is doing things in parallel, doing things at the same time. Distributed application gives you a lot of powerful flexibility for running things in parallel, and being able to express that in your workflow is super beneficial. Error handling and recovery, very important for AI, particularly when we're talking about handling not just format of data, but also things like hallucinations, right? If you've ever gone and done prompt engineering, you're familiar with the idea of having an AI or LLM return something that is just either completely wrong or completely unrelated to what you asked for, and there needs to be some mechanism in place for detecting those things, right? So building the logic into your workflow is going to allow you to not just detect when those things happen, but detect when they happen and have, as we were talking about on the previous slide, like an audit trail of that, right? You can see historically, how often does the model hallucinate? Where are these hallucinations occurring? What form do they take, right? And having that visualizable within a context of the workflow is super, super useful. Similar monitoring and control, right? Whether it's monitoring and control of errors or monitoring and control of just a day-to-day basis of knowing what's going on, having a visual representation of the decisions that your AI agents or, again, your human agents are making is going to allow your business to operate more efficiently. And then finally, everyone's favorite, or very often least favorite topic, security, compliance, and governance is a difficult problem to solve in any context, but particularly in this budding new field of AI, where a lot of organizations don't have formal controls in place yet. So a lot of companies have the blanket statement of we're just not going to use AI because it's too hard to develop a policy around what they should have access to. By having those controls built into the tool you are using to orchestrate your workflows, you're able to get a lot of that out of the box without needing to have a very formal definition of the AI, the systems the AI can use, because they're going to be given the same like blanket of controls that your human agents have, right? All right. Strategies for scaling. Again, not all of these are AI LLM related. First one just kind of comes along with distributed, highly scalable application. The real-time feedback and monitoring loop, this is something that you're going to want to do. I mean, this is essentially, you have a chat. I'm sure we've all opened ChatGPT. We've opened Gemini, right? We've gone and asked it questions and gotten answers and seen the thought process there as it went through. Being able to visualize that not as a chat, because it might not be a process that is ascribed to a chat format, a call and response. It might be a more long-running several responses in a row that call database systems, right? And you want to be able to see that and monitor that and potentially change your future inputs to your LLMs based on that. Humans in the loop, AI are really cool. They're fun. But sometimes you just need to bring in a real person. And by using a workflow orchestration engine like this that gives you that human in the loop capability, right? We're able to go ahead and escalate in some cases to those humans, to those people. This is particularly useful if you have some kind of approval flow. If you're an insurance company, right, and you have to go ahead and approve a claim, well, more likely than not, you will want a human to look at that eventually, but you can use an AI or LLM agent to take out the first few steps to say, hey, if there is just a very obviously incomplete application, there is a decision that needs to be made along that, and AI can reason about the first, like, hey, ask them for more information. Probably want the human to look at it eventually anyway, but the AI can get the first steps out of the way. And that's going to be a feedback loop, right? That's going to be happening multiple times, and you need some way of modeling that process. Orchestration's everywhere. I've already kind of said this a few times, right? This top little bubble here where we talk about indexing and LLM query, this is where like things like retrieval augmented generation fall under, right? Those are AI related. All of these other things around it are the things your businesses are already doing. And bringing an orchestrator in to coordinate between the things your businesses are already doing and the other things that your business wants to be doing, and the AI and ML related tools that can help you do those more efficiently is really going to be a better way of operating, right? Because you're able to go ahead and tie all of these systems together. All right. I've talked a little bit about Conductor, which I haven't really elaborated on yet, but is what my company works on, right? Orkes, we develop Orkes Conductor. There is also an open source version of Conductor that was started at Netflix a number of years ago. We do maintain the open source version of Conductor as well as the enterprise version of Conductor. Essentially, it's a distributed decision maker, right? It's an orchestrator, it's a router, it's a state machine handler for you, right? And so you develop your workflows, you develop your applications using Orkes Conductor as the source of truth for the state of your application, and then it goes ahead and does things for you. It can do things like call APIs. You can have service workers that interact with Conductor that are owned by specific teams, by specific organizations, or even specific developers, right? You can work with humans in the loop. If conductor is the epitome of all state, you have humans that can go in and provide input, right? They can validate output. And then finally, enforce deterministic output. As with any application, you expect some output to be how it should be, and you should be able to validate that and recover if it doesn't, right? I know not all of the people in the room are necessarily technical experts, but there are SDKs involved. So if you are going to be writing code at some point, you have your choice of SDK. For Conductor, you have Java, Go, Python, C#, JavaScript/TypeScript, and Clojure available to you for going and actually interacting with Conductor. That might be building workflows, that might be building specific tasks that you want your AI agents to be able to invoke. That might be, like I said, the workflows, and the workflows can contain invocations of AI LLM agents, right? A lot of flexibility for you so that your teams can work cross-functionally in whatever programming languages they prefer. And, got a couple more slides here before we can hop into the fun part. Agent to identify with function to call, dynamic function calling within Conductor, decision cases to pick one of these. I'll be showing this like live in a second here, so don't worry too much about this slide. Essentially, we're able to have long-running processes though, right? If agents are the ability to make decisions, we want to make decisions not just ahead of time about what our application can do, but also down the road, right? We want to make decisions on the fly as an application is running, as the process is being handled. And here on the right, again, don't worry too much about this diagram, but if you're familiar with programming, this is a loop. It is doing a certain process multiple times, and on each iteration, it is calling an LLM model, making a decision, doing some external transformation, and then waiting for human input again. So this is how you might model like a chat application, right? Something similar to ChatGPT, to go ahead and get input and then do something with that output afterwards ad infinitum, right? And at each stage, you can see what the inputs and outputs are. So you can see what chat message came in. You can see what the LLM produced, right? And this is just elaborating a little bit on that. Here we already talked a little bit about Conductor and Conductor OSS, what we offer, right? Polyglot SDKs, integrations, all of that fun stuff. It is Apache 2.0 licensed, so you can go online and fork Conductor and run it yourself if you want, if you are interested in running the open source version. We do also have Developer Edition. So what I'll be showing you in just a second here is the Orkes version of Conductor, which has several bells and whistles on top of the open source version, including some pretty tight AI LLM integration, right, to make it super easy to write prompts and to invoke your models. You can play with all of that stuff on the Developer Edition as well if you'd like. So what does that look like? Well, oh, it full screened me to the wrong side. There we go. Here I'm going to just play with Orkes Conductor a little bit. I'm going to show you an example of building out a very simple agentic workflow. It's going to take some really silly input and make a decision based on that, right? And so we're going to go ahead and start by just defining a new workflow. This is going to allow me to basically build the shape of this process, to define what is going to happen when this process is ran. Again, we're going to do something really silly, so we're going to name this something along the lines of favorite, or let's be a bit more descriptive. Add, and it is really hard to type with one hand while holding a microphone. Add movie to favorites. Does this work if I push this button? Wow, technology. Cool. So we're going to add movie to favorites, right? This is going to add a movie to a user's favorites. And so what it's going to take as input is a few things, right? Firstly, we're going to pass in some user ID. We need to know what user is favoriting this movie. We might have a movie ID as well. If we're like IMDb or some other website that has a database of all the movies we support, we're going to need to be able to reference that somehow. Next, we can start adding our tasks. We can just start saying, hey, these are the things you're going to do. A very basic example of a task that we might add is an HTTP task. Lets you call some API, right? And for this, we're just using this dummy API that doesn't really do anything. But we can go ahead and pass into this API. Maybe we pass in that movie ID to get that movie's information. If I actually ran this task, right, and we passed in the movie ID 1, 2, 3, 4, that's not going to matter much, but it will return some result, right? So it returns this random string, and we can then use those values later in our workflow. So we can already see how we're going to take these outputs of like an API call and tie it in and provide it to an AI model down the road, right? So let's say we want to, after this API call is made, we want to ask the LLM model, tell me things about this movie. Is this a good movie? What genre is this movie in, right? If that's all stuff we have in our database, then this API call will return that information, and we can pass it into our LLM model. Now I'm going to go ahead and just go write a really quick prompt, right? We're going to add an AI prompt, and don't worry too much about the prompt engineering side of things, because that is a whole complicated system and science all of its own, right? But we're going to give this a name like, was this movie good, right? And obviously, if I were in IMDb type business, I would probably have a more analytic model or a more data-oriented approach for finding out if a movie should be considered good. But if you were making other decisions based on purely logical reasoning on historical language processing, right, then you might use an AI to make this decision. I've already added the integration with these models with Gemini, so I am using the Google Gemini models. Google Gemini 2.0 Flash is a really solid general purpose model. Description doesn't really matter, so we're just saying description. But now we can type a prompt template. So we want to find out if this movie was good. We can say very simply, a user added the movie name, and you'll notice it pops up on the right to say that we will need to provide a movie name to their favorites. Is this a good movie? Now we're going to test this model, or test this prompt with this model. What's a good movie? I think Fight Club is probably a good movie, but let's see what it responds with. That's a lot of data. Now, in reality, if you were building an agentic workflow, you would probably specify a JSON schema and say return a valid value that conforms to this JSON schema, and then you could parse that and use that in your actual workflow as like data, and thus use that to make decisions. But for now, I'm fine with this output. We're going to save this and confirm this. And if we go back to our workflow definition and select our LLM, we have the was this movie good prompt, and we can provide a value to movie name. Now, I showed you earlier I made an API call before. If I wanted to use some part of the output of that API call, I could do so, right? In this case, that API call doesn't contain anything that is a real movie name. So we're just going to put a hard-coded value here for now, Happy Feet, right? We want to know if Happy Feet was a good movie. And let's make another API call to that same endpoint. But this time, we're going to use the output of our LLM prompt. So we'll take this output.result. And if you notice, this takes in the movie ID, doesn't really matter what that is. This has some input for Happy Feet, and this has some input for this bogus value, which again, doesn't really matter at the moment, but that's okay. If we save this workflow, and now we go ahead and actually run it, we can provide dummy values for movie ID and user ID, which will not actually matter. But when we run the workflow and we call our LLM model, we can go ahead and see the input that this took. And so hopefully you can actually, let me zoom in a little. So now hopefully you can see that for our prompt variables, we passed in movie name, which again, I hard-coded Happy Feet, but would more likely than not be the result of a database call or some other API call, right? And if we go ahead and refresh this, now that it's finished with that inference, we can go to the output of this task and see this entire result here. Again, whether or not Happy Feet is a good movie is subjective and depends on individual taste. But then our next API call is taking that same big response and using it as input. So whatever your AI does, whatever your LLM does, I'm not going to teach you how prompt engineering works. That's, again, huge conversation that needs to be had. But you can already see we're able to pass inputs around. We're able to produce outputs for these workflows. And depending on if you had decision-making in your workflow or looping in your workflow, these could very easily represent long-running processes that are capable of acting on their own or making key business decisions for you along the way, right? The extent to which you want to do so is going to matter very largely on your business. But you can see already that being able to automate these processes is a super powerful ability. I think that aligns me up to about 30 minutes. So I am happy to take Q&As or... Yeah. So if there are any questions from people in person or online, yes, sir.
Great. So this is super cool and great demo. Thank you for explaining it so well, so quickly. So my wonderment is, do you have any kind of chat-like interface to make it easy to describe the kinds of workflows you're doing? And then the second question is, since I tend to do everything in code, is there a way to just do this via code?
Yes, wonderful questions, both of those. So I'm gonna actually answer them in reverse order, if that's okay with you. So firstly, let me go to my workflow definition. This is the workflow definition editor. It is a visual editor that we offer. At the end of the day, the workflow is a JSON document. It's a JSON DSL, right? This is actually an open format. So I guess I'm kind of answering your questions at the same time. This is an open format. This is the same format between the enterprise version of Conductor and the open source version of Conductor. So if you go to the open source version of Conductor, we've got several examples for workflows in JSON. Well, the open source version of Conductor has been around for years and years and years. So if you go to Gemini or ChatGPT, you can actually ask it to write a Conductor workflow to do certain things. Now, that's actually not why I have ChatGPT open. I guess I could ask it to if you want. But in addition to that, we are currently working on a product to allow you to have a more tailored Conductor-specific ChatGPT-esque offering that will also allow you to do things like define database connections and other infrastructural connections, because this format for the workflow itself, well, that's an open format and very well understood by ChatGPT. Things like, how do I define a JDBC query that can be formatted specifically into the API call that I need for Conductor to connect it to my workflow, right? Those are a little bit more obscure. So we are going to offer that fairly soon. The other question you asked was related to defining workflows via code. Yeah, most, not all of our SDKs, most of our SDKs do support workflow as code as well. So if you wanted to write your workflow using Java, you want to build a Pojo, you totally can. Go, C# also do. Python, I don't think JavaScript does support it, but it's out there, right? Yeah.
Thank you. So my question is more about the business use cases. So it's up to whatever you want it to do. But so far, do you have any specific workflows or use cases that people have a lot of interest in using or implementing?
Yeah, absolutely. So I'm going to take a step back from the AI lens for a second, because AI is still relatively new and people are still experimenting with it. Conductor itself was started by Netflix in the early 2010s as part of their move from on-premises data centers to the cloud before there was a good workflow tool in the cloud, right? And so Netflix originally made it to handle all of their business processes, from login to ad serving to determining what title to show you, right? Those were all various parts of processes that were handled by Conductor. That was how it started. In today's day and age, it handles basically any kind of process where you want things like failure handling, observability. I can give some very fun examples. I think my favorite example, my favorite example is a medical device. I don't remember if it's a CAT scan or an MRI machine, but there's a medical device where they run the open source version of Conductor locally on the device to run the processes to actually do those medical scans. We have NPR uses us for doing various parts of their pipeline for video, audio transcoding, right? There are a lot of other media ones. I'm not exactly sure who is publicly referenceable. Maybe, let's see. we have shipping logistics customers, insurance customers, finance customers who use us for handling application processes and pipelines, right? Some functionality that you might expect from a like business tool. So things like defining a cron job to go ahead and run a process at some periodic interval, right? That's a very popular thing that businesses need to do. And a lot of businesses will do them, particularly old guard businesses. Some people have actual like PowerShell scripts running on an individual laptop in a conference room somewhere that does this every 24 hours. So being able to centralize that kind of thing, right? Let's see. Is there a particular business use case that's interesting to you? Yeah, it's a very general purpose platform. If we want to talk a little bit about like the goal of Conductor and the goal of Orkes, or some goals anyway, a lot of the ideas is this is the way you should build systems and applications, right? You shouldn't need to worry about spinning up a Kubernetes cluster yourself and a database yourself just to do very simple state management. You probably still will need to spin up a Kubernetes cluster or a database for the foreseeable future at some point for your business. But for your day-to-day activities and for managing processes, that's totally overkill for most business units, right?
Few question. I was just trying to logically connect the Jenkins pipeline to the Conductor agentic workflow. So what if something fails in between, right? So how can you remediate that, like, and in a maintenance fashion, like, lifecycle management?
Yeah, several different ways of doing so. And I'm going to tell you, firstly, I think the easiest and most widely used, right? If we go to our workflow here, and I'm going to zoom out again a little because it's kind of overwhelming. Let's say this workflow fails. We want to handle that failure in some way, right? Actually, before we even get into that, let me go ahead and make it so that this API call fails. We're going to make this call to .comma, and because that's not a valid domain, when we run this workflow, it's going to try to make that API call. It's going to fail. This workflow is going to fail. Nothing worked, right? If we go back to the definition, there's a very handy setting called the failure workflow. This is very similar to a try-catch, right? It's if this thing fails, do something else. And so in this case, maybe we want to call the alert workflow. And so now when I call this workflow and I go ahead and actually click run, right? This workflow is still going to fail. I didn't fix anything. It's still going to make an API call to something that doesn't exist. But now you'll notice in the top, there's a little bubble that says triggered failure workflow, right? And if I go over to where that is, it's a pretty boring workflow. It doesn't actually do anything, but we could do whatever we wanted here, right? We could trigger a Slack notification or a PagerDuty notification, or this workflow that we've triggered as part of our failure actually gets the entire state of the workflow that failed as input. So we can actually go ahead and make decisions within our failure workflow about the other workflow that actually failed. We could undo things that it already did. We could go ahead and make reasoning and logical decisions. And that's something you could even involve an AI or LLM to do, right? Yeah, and there are a lot more niche ways of handling failures as well, but that's probably the most general purpose.
Hey, congrats. Looks like a pretty cool app and project. I was curious. I usually use Zapier to do similar stuff, just connecting it to ChatGPT to OpenAI or to Gemini, and I can create workflows that way. I feel like that's more like a no-code solution, and I'm just curious, is this like kind of a similar type of idea, but more focused into developers?
That's a very nice way of like kind of summarizing it towards the end there. We try very hard not to market ourselves as a no-code or a low-code tool. We do have customers who are using us, who have like certain business users who are using Orkes Conductor and logging in and making very simple workflows. But day to day, the general people that we're targeting are developers, are engineers. I didn't really show much of building individual tasks or like writing code that interfaces with Conductor much, but For the most part, these workflows that you're going to be defining are going to be made up of these tasks. And these tasks largely will contain your business logic. These will contain your code. And these are things that you will need engineers or developers to come in at some point and say what's going to happen, right? Now, there are aspects of this that you can hand off to business users. In particular, right, if we had a human in the loop task, which goes ahead and shows a form to someone, that form could likely be filled out by someone who has no lick of computer literacy, right? But the workflow definitions, the individual tasks will very largely be used by engineers, by developers. Conductor is kind of first and foremost a microservice orchestration tool, right? And that's how I tout it to a lot of people when I'm talking to people who are more engineering oriented. When we're talking about workflows, like you said, a lot of people think of Zapier, or there are a couple of others that are more business oriented, right? That are meant for people to do very, very quick and dirty automations. But yeah, it's an engineering tool primarily. Yep.
Right. Okay, and let's take a couple more questions.
So is there a general use case for this for iterating on code? Just like if you want to write a small script, I will generate small scripts on the first try a lot of the time using ChatGPT, but sometimes I do kind of iterating just to fix out some bugs or improve it a little bit. And sometimes I'd like to just kind of let it iterate automatically, check did it compile or not. Have you done anything like that with this?
So that's definitely part of what, I don't know if the project name we have for it is public yet, but the tool that I was mentioning earlier that we have that's doing agentic workflows, and that is particularly creating agentic workflows agentically, right? In which you can kind of conversationally create the workflows that you want. That is taking largely a more iterative approach, right? When it comes to building workflows manually, like in our UI here today, like you kind of saw me clicking through and doing, there is not currently, and I don't think we have a plan to bring AI and LLM into that experience in particular, largely because a lot of our customers do have a lot of data privacy concerns. And so bringing it in as a blanket feature for the product, we're not quite there yet, but it will be a part of the agentic focused product.
Thanks.
All right. Any other questions before we wrap up? Going once, going twice. Okay.
Cool.
Thanks, Haven. That was a very informative session. Thank you. And you're going to be around to connect and then the after. So yeah, if you guys have any detailed questions and so on, he's going to be here after the second talk. Speaking of second talk, we're going to bring up Dave.
There we go. All right, can you hear me in the back? Okay, awesome. Let me get things going here. Okay, there we go. I'll start with the microphone. Yeah, I'll start with the microphone, and if I need to come back over here, I will, kind of a thing. But yeah, so what I have kind of queued up this evening, GitHub Copilot has evolved a lot over the 3-4 years that it's been out there, right? How many are using GitHub Copilot today? Okay, fair amount of you. How many are using GitHub for source control? All right. How many are using other tools like Jira? There's a few. Okay, Cursor. I'm just thinking right now the whole DevOps stack kind of a thing. So JFrog. We're using JFrog Artifactory. Okay, I see one hand there. Sentry. Okay, a few hands there. All right. Well, part of what I want to talk about is how AI powered DevOps with GitHub and GitHub Copilot and GitHub becoming, really going beyond what used to be just that source control platform to becoming the backbone of your DevOps tool set. And, we'll talk about how these other tools and things plug in. But yes, we're also going to be talking about where we've come and where we're going with things like agents and that. So yeah, GitHub Copilot started out, either in chat or right in my editor. I could type in some comments, say, hey, I need a function to do XYZ or whatever. And it would give me that code, real-time code suggestions, allow me to add comments to code. One of the next things we're working on is what we call next edit suggestions. I think we'll see a bit of that in one of the demos. But one of the things, so kind of the idea here is for those of you that are here every month, I come up and I'll say welcome, and then I'll say, hey, here's some of our latest announcements. Well, now that we're using AI, man, the pace of change is just incredible. And so, even just in the last month or so, there have been quite a few announcements and things. One of the things we've talked a little bit about, and I think we even had Sharon Lowe here talking about GitHub Copilot extensions a few months ago. But last week, GitHub Copilot extensions became generally available. And so that's kind of why I mentioned, tools like, where'd it go? Atlassian, so Jira and Confluence, or JFrog or Sentry, if you're using things like Launch Darkly for feature flags and things like that. Everybody's using all of these tools, but now using them with Copilot extensions, you can really stay in the flow. You can stay on github.com, or you can stay in VS Code or JetBrains or whatever, and just say, hey, Atlassian, what issues are assigned to me, in Jira? Or Atlassian, what is in our Confluence knowledge bases about XYZ and all that? And you don't even have to know what the URL is to get to your Confluence instance and things like that. So with GitHub being the backbone of these DevOps stacks, and with the, we're bringing AI from these other tools right into GitHub. So we're really making the whole greater than the sum of the parts because of all this AI and everything keeping you in the flow. So here's an example of the Jira Confluence. Jira and Confluence extension. And, so I'm in Visual Studio Code and I say, what are the spacing tokens that I can use? And this information that's coming back is coming right from Confluence. So, and then another great example here was saying, hey, Atlassian, how do I roll out a feature? And, it does reference Launch Darkly, a third-party tool, but this company also has Switcheroo. It's an internal tool. So by asking Confluence about it, it's able to see and get information about these internal tools and things too. And again, staying in the flow. I'm right here in Visual Studio Code. I'm just chatting with Copilot. All right, the next thing that I want to talk about here is Copilot code reviews. And we actually have a little demo of that. Oh, you know what? Let me, I didn't share sound. There we go.
Let's use GitHub Copilot to get initial feedback on our pull requests on GitHub. With Copilot Code Review, you can ask GitHub Copilot to take a first look at your code before asking your team for a final review. Once you've pushed your code to GitHub, navigate to the pull request, select Reviewers, and choose Copilot. After some time, Copilot will add comments to your PR. As you see here, I'm getting some really good feedback about referencing a non-existent table in my query and some additional feedback about syntax errors I seem to have overlooked. I can accept these suggestions by clicking the Commit Suggestions drop-down menu, then press Commit Changes. This will update the file with the suggested changes right on github.com. I can also batch accept suggestions by clicking the Add to Batch button. When you're finished with your PR, you can request additional reviews from Copilot and go through accepting the suggestions once again. Copilot Code Review is now in public preview, so if you have feedback for us on this feature, you can use the thumbs up or thumbs down button to let us know what you think. If you click the thumbs down button, you'll be prompted for additional information to continue improving the product. If you have access to the public preview, we'd love for you to give Copilot Code Review a try and tell us what you think.
All right, in the interest of time, I'm going to move on. So another thing we're expanding is the editors that you can use GitHub Copilot in. You know, it started out Visual Studio Code, NeoVim. We've worked our way into JetBrains and that, but now we've also added Xcode. So for, you know, if you're working in Xcode. And so here, I'll post a PDF of this presentation here so you have all of these links, but these are some of our recent changelog announcements. You know, the last meeting was, I think, January 22nd. So these have all been announcements since then, actually. But code completion for Copilot is now available in Xcode. Copilot Chat is in preview for Xcode. And when it comes to Eclipse, we now have code completion out there in public preview for Eclipse. That's pretty new. We're bringing the multi-model selections to the JetBrains IDEs, IntelliJ and PyCharm and all that. So GPT-4o is now available for code completion there. And there was another update related to JetBrains saying you can say at project. So when you say at project and then ask a question, you're really pulling in that entire project as context when you're feeding the prompt to Copilot. There was a notable update with Visual Studio 2022, numerous things like multi-file edits and GitHub Copilot free even being usable from Visual Studio. And all of these were at the GitHub changelog. And I should have said changelog/Copilot because that's our entire changelog. There's new stuff coming out every day there. All right, now let's kind of dig deeper into some of the new exciting stuff with Copilot. So the first phase of Copilot was single model. And yes, it was conversational coding. That's great. AI infused and everything. But now we're looking at multi-model, giving you choice of what model do you want to use, not just not just GPT. We're talking about agents. So brainstorming agents, code review agents, code completion agents, test agents, etc. And AI just being native in all of this. And one of the things, if you aren't multi-model, you will be disrupted. We actually kind of felt that ourselves before we started adding the model picker in there. But now we've got multiple choices. And just the nature of the way things work, we have very close association with the VS Code team. So these choices come to VS Code first, but then over time roll out to the other IDEs like JetBrains and Visual Studio and Xcode and all of that. but we had several announcements again, just since, within the last month or so. GPT-4o Copilot code completion model available now in VS Code. So one thing to know is when you're doing something in chat, you can pick a model. That's not necessarily the same model that's being used for code completion, right? So you go into the settings and say, hey, what model do I want to be using for code completion and things like that. Google Gemini Flash is now available to Copilot users. That's in public preview. OpenAI 3 Mini is now available in Copilot and also Copilot models. And then this was just announced, I believe, yesterday. Claude 3.7 Sonnet is now available in public preview as well. So we're continually looking at and evaluating the models and stuff. I don't think I have the link in here, but if you just go to the GitHub blog and look back a few weeks, there was a blog post that talks about the process that we go through to evaluate models and things like that. We don't just say, oh, great, hey, there's this new model here. Let's start using it. No, we do our analysis, make sure we're getting great coding suggestions, making sure we're not taking a hit performance-wise compared to, maybe the previous version of the model and things like that, because we want to keep you in the flow. We don't want you, we don't want you sitting there a long time wondering when is this, going to come back. We want to keep things moving. So performance is very important. And again, these are things that are all available at the changelog. Agents. Yes, our CEO, Thomas Dohmke, had a post just earlier this month talking about the Agent Awakens and software engineering agents, SWE agents, and talking about how we're seeing 2025 being the year of the SWE agent. And some of this starts with GitHub Copilot Workspace. Even before you start coding, being able to describe in text what it is that you want to do. And again, don't go straight to code, but say, have Workspace build out a plan for you that says, okay, yeah, we need to do this to the database tables, and then we need to do this to our UI code, and we need to do this to our business logic. And you, as the Copilot, can look at that plan and say, hey, and I know, we want to make note, we expect to have 1 million users. So we really want to make sure the code is written for load and scalability and things like that. And then you take it and turn it into code. So I think the next thing here is...
Starting with your work usually takes place looking at a project board and navigating to GitHub issues. Copilot Workspace brings your favorite AI assistant into a native dev environment designed for everyday tasks. For example, it can use the information in your GitHub issue along with references from your repository to build out a specification based on the current state and proposed state. And you can tailor the spec as you need, whether that's adding, editing, or removing items. Once ready, you can progress from spec to plan, and the process feels familiar, with the ability to adjust the plan as you need by creating, modifying, or removing files and adjusting the expected tasks for each step. This leaves you in control, free to solve the higher level problems and build out your plan before getting into the finer details of writing code. Copilot Workspace then streams the suggested changes to our environment. Notice that we have a diff view to easily digest the changes and can easily make updates within the editor. But that's not all. At our fingertips, we have access to an integrated terminal, so we can run the tests in our workspace before committing our changes and creating a pull request. And what if you want to make use of advanced features like step-through debugging? No problem. Create a code space and pick up where you left off. When you raise your pull request with Copilot Workspace, it generates a description for you and automatically adds a link to your workspace, adding a little bit more context for the reviewer and supporting their code review workflow. And as it's a pull request, our usual checks trigger, including GitHub action workflows and code scanning. Copilot Workspace leaves you in control, solving the high-level problems and iterating quickly over the solution.
All right, so yeah, the next reference here is again to Thomas's blog post, The Agent Awakens, and talking about how, we see the role of developers evolving, right? Developers may not be hands-on writing so much code and things, but giving prompts to things like Copilot and triggering different agents and such. So the role of developers becoming really orchestrating the work of all of these different agents more so than writing all the code themselves. But, and this is what I say very often when I'm talking to customers, notice we called it Copilot. We did not call it autopilot. This is not something that's going to just full on replace developers, because you always want that final human reviewing the code. You want the human coming up with those detailed plans and prompts and things and all of that. So yeah, we refer to it as Copilot, not autopilot. All right. Now this one, the demo is not embedded, but yeah, I want to talk about some of the things that are coming very soon as far as the agents and things.
The February 2025 updates to Visual Studio Code make Copilot an even more powerful AI pair programmer. For starters, until now, GitHub Copilot in VS Code's editor worked from your cursor position. Next edit suggestions means Copilot can now offer suggestions on the next edit you might need based on the changes you've been making. We started creating a runner class, but after creating the constructor, we get an error because we forgot to set up the fields. Next edit suggestions detects we probably want those fields, so makes those suggestions. We can manually accept or reject by using the icon on the left, or select tab to complete the operation. Next edit suggestion then suggests a getInfo method to provide read access to the runner data. Let's accept these by selecting tab to move to the edit, and then tab again to perform the accept. Now it's time to add in shoe preferences. Copilot suggests brand and size, and after creating the interface, Next Edit Suggestions realizes we likely want this on the runner. It adds the field, the update to the constructor, and then finally to the getInfo method, allowing me to tab through all the suggestions and code that much faster. Looking at a larger task, we have a website called Runner Tracks, which has a page that shows the results of a race. We want to improve the paging for our table, as there can often be a lot of participants. We can use Copilot Chat to make a change to the Svelte file we have open here. I'm going to use the model picker and choose one of our newest options, OpenAI's O3 Mini. We ask Copilot Chat to make the buttons look prettier, then apply the suggested changes. Let's check, and yes, those blue buttons look much nicer, so let's accept the change. With that complete, let's keep iterating. We want to let the user select how many rows they want on each page. This will require more than just one file change. Copilot edits can make suggestions across a number of files. We can let Copilot find the files to change, but let's add in a few files to the working set and then ask for the change. You'll see in this case, I'm using Claude 3.5 Sonnet, demonstrating the ability to select different models. Copilot Edits has the suggested changes to all three of those files in one go. It even gives me a summary of the changes it's made. Let's save, take a look at the site, and there we go, a working dropdown to select how many rows the table should display. However, our team has even more suggestions for the UI. And what more common way to explain what they want than a screenshot with some hand-drawn markup? Until now, Copilot Chat could only work with text, but now Copilot has vision capabilities.
we can attach the image by pasting and ask Copilot to implement the changes shown in the image. We'll apply those changes, save the file, have a look at our website, and sure enough, the column alignment has been fixed, and just from a screenshot. Let's turn our attention to an even more complex task. Our Runner Tracks website has a page listing races, and we want the ability to search for a race by name. This is going to require changes to a number of files in our project: services, server-side code, UI, and tests. Copilot now supports agent mode, allowing it to reason and iterate over an entire project to perform complex operations. Copilot starts by exploring our project to determine what updates need to be made. It begins updating the backend service, and then the UI making the necessary changes. Once it completes those, it turns its attention to the tests, the unit tests for the service and the page, and the end-to-end tests. With the tests updated, we're then prompted to run the unit tests. Our unit tests fail because the existing ones didn't align with the new functionality. Copilot detects this issue and makes the changes, prompting us to then rerun the tests. When those succeed, we're prompted then to run the end-to-end tests. We can see I forgot to stop another testing process that was using the port. Fortunately, Copilot is there to help me out, generating the command to stop the process and run the tests. Everything passes, and if I look at the website one more time, I can see the new functionality. Finally, let's build some backend services. We want to allow our Runner Tracks website the ability to associate races with fundraisers. We need a fundraiser service modeled like the other ones we have in our app. It needs to understand the structure and the schema we've been using in the rest of our codebase. If we ask Copilot naively to create the service, it lacks the necessary context to both understand that underlying schema and how we want the service to be constructed. Context is key whenever we're working with AI. Let's start things over, but this time we'll reference a prompt file to give more specific information about how we want things implemented. Prompt files are markdown files kept in the .github/prompts folder of your project. They can even reference other files, in this case a Prisma schema that describes the shape of our database. We have notes about our code preferences, and we've even included a template for how we want our services constructed. When we send the prompt again, you can see that extra context means Copilot does a much better job this time. This looks like exactly what we want, thanks to Copilot and our prompt file. With the new updates to Visual Studio Code and GitHub Copilot, you have an additional set of capabilities to allow you to be even more productive.
Yeah, one of the things I thought was really cool there was the Vision API, right? He grabbed a screenshot, marked it up and said, hey, I need name and place to actually align with those columns and everything. And then just pasted that screenshot into Copilot chat and said, can you make these changes? And then below, I kind of line things up there so you can see the changes that Copilot actually made. So, making it even easier to and more productive to get through changes like that. All right, now he started to talk about agent mode, but next up we've got, so when you go to that blog post from Thomas earlier this month, our CEO, he talked about Project Padawan, kind of the next level of agentic AI in GitHub Copilot and all of that. So the software or the autonomous software engineering agent.
The GitHub CLI is used millions of times every day and has a backlog of many issues despite hundreds of contributors. Let's take a look at one of the issues. We have a bug report here which highlights a missing validation in the gh repo rename command. This is a kind of improvement that might be on the backlog for a while before being worked upon. What if you could hand this off to your AI assistant so that you and your team can stay focused on the big picture. We are working on a new Copilot agent which will make this a reality. We can assign the issue to Copilot, which picks up the issue right away and gets to work. There are about 200,000 lines of Golang code across 700 files in the repo, so Copilot has to do some work in the background to figure out what to do. After a few seconds, Copilot spins up a draft PR and links it to the issue we created, which we can see in the issue timeline. In the PR description, Copilot has shared its implementation plan, so we know how it is approaching solving the issue. As it continues working on the task, Copilot keeps updating the PR description and pushes incremental commits, so we can follow along to its progress on the changes. A few minutes later, Copilot updates the PR description with a summary of the changes it has made once it has completed working on the PR. It has also pushed commits with the final changes, requested a review, and marked the PR as ready for review. Let's take a look at the changes it has made, which are across multiple files. We can see that it has implemented a fix for the bug while also following all of the conventions of our repo, like code style. Copilot has also updated the tests and run them to make sure they're passing before pushing the code. While reviewing the changes in the implementation, I noticed that showing an error message to the user would be helpful if validation fails. I can ask Copilot to improve that. I will select parts of the code and add a comment that specifies to add an error message. I will submit my PR review requesting for changes so Copilot can make the necessary modifications. Copilot reacts to my comment to let me know that it has seen it and is working on it. Soon, Copilot replies to me with a detailed comment on the changes it has made and also pushes updates to the PR addressing the comment. Let's take a look at the changes it has made in the PR. There it is. The code looks great now, so I'll resolve the conversation and approve the PR. I could accept Copilot's changes and merge right away, but I want to make some more changes myself. As a developer, I remain in control and I can continue making changes to this PR as needed. I'll head over to my VS Code where I've been working on this repo. I'll check out the PR locally so I can make some modifications to the same branch. I've noticed that the help text for the repo rename command can be made more clear by specifying that this command cannot transfer repos. Let's commit the changes I made and push to the branch that Copilot originally created for the PR. Heading back to the PR, we can see my commit alongside the commits made by Copilot. PR is looking good, so I can go ahead and merge it. And there it is. Copilot was able to pick up existing tasks and make changes, becoming truly a part of your team. With Copilot, you'll soon be burning down that backlog faster than ever.
All right. So this was announced actually a couple of months ago, but just want to make sure everybody's aware. We now have a free tier or a free plan, if you will, for GitHub Copilot. It has most of the features of GitHub Copilot individual plan or the GitHub Copilot business plan. But, a key thing to note there is, you're limited on how many to 50 chat messages per month or 2,000 code completions per month. And I'm not necessarily a hands-on coder these days, but I've heard numerous people say that's actually quite a bit. They're able to get quite a bit done with that. But if you actually, let me go to, when you think about the amount of time that Copilot is saving you, yeah, Copilot Pro is $10 a month if you're, independent. If your company is buying Copilot, they're probably buying Copilot Business. And then, within their GitHub organizations, they can manage who gets access to it and things like that. And you can go to this page and compare the differences and things. But, one of the things I often ask customers when I'm talking to them, it's like, okay, given your engineers' salaries today, how many minutes a month do you need to save to pay for that $19 a month if you're going for the Copilot business plan? I had pulled, the average salary for a software developer off of, I think it was the Bureau of Labor and Statistics or that, did the math, and it's like, if it can save you 22 minutes per month, it's paying for itself. And, we've got data out there where it's saying, saving hours per day or hours per week kind of a thing. So the savings in time and the increased developer productivity, is huge compared to the price that you pay. But yes, you can start out with the free version. All right. So shifting gears just a little bit here, I thought I wanted to highlight this post that I don't remember the exact date, but again, it was just within the last month, but talking about how open source AI is already finding its way into production. So in that post, we talk about exploring how and why companies are using open source AI models in production today. And you can learn how open source is changing the way developers are using AI, and look ahead at how small open source models might be used in the future. So I'm not on Discord yet, but I'll make sure I get out there, or I'll make sure I get the PDF of this over to Josh or Bill so they can post this on Discord, and I'll try to get it out there on my LinkedIn as well, so you've got access to all of these resources. Now, in general, if you want to take a picture of this one, this is like pretty much all the links that I can come up with between blog posts and documentation and our YouTube channel and things like that. So, you can get access to all this Copilot information in that. Oh, and yeah, okay. And then I didn't really talk about it tonight, but I've talked about this in the past. In the GitHub Marketplace, we have created what we call GitHub Models. It's a playground where you can go and pick Mistral or Llama or ChatGPT or whatever. You can pick different models and play around with them, try different prompts and things. And that's evolved to where you can even pull up two side by side and put in the same prompt and compare the results of what comes back. And then, oh, okay. Oh, okay. Okay. Got it. Okay. Actually, yeah. Okay. Okay. Sorry about that. No, we're talking about models. After you play around with, a couple of different models in that, you can say, hey, I'm writing a Java application. So what would the Java code look like to take and plug this into my application? Or what would the, .NET code look like to plug into an application? So it gives you a great playground to go and play around with models and figure out how to start implementing those in your code. And then you can use like Azure's AI services in your applications to actually implement them, full bore in your applications. All right. So that's what I had for tonight. Hopefully there was something new there that you learned this evening. See everybody nodding. Okay. Yeah. So it's tough to keep up with those resources. I'm working on putting a blog post together that's just going to be a monthly, in case you missed it, kind of summarizing blog posts and documentation updates. One of the things, we recently added a Copilot chat cookbook to our documentation so that you can see examples of different types of prompts and things that you can use with Copilot. There's just lots of resources coming out all the time. So with that, yeah, we'll see what questions. Do we have any questions this evening?
Yep. Ready.
Hi, I'm just curious. You were talking about Copilot being a copilot and not autopilot, but after seeing Padawan, it doesn't seem like an autopilot is too far off. And I was just wondering sort of if that is something you're thinking more about as you develop these tools, because it's getting close to it being able to develop a repository on its own. And so I'm just curious if there's, yeah, what your thoughts are on that.
Well, the way we see it is, it's going to make developers more and more productive. Developers are always going to need to be in the loop. You're not going to just hand this to somebody straight out of college and say, "Oh, good, I can replace that 20-year developer whose salary is up here now and just have this recent college graduate do it," right? Because that 20 years of experience still comes into play when you're reviewing the code that Copilot is creating or generating those prompts that say, yeah, I'm starting this new web app off the ground, but I know the last time we did this, when we started getting to the point where we had 1 million, 2 million users, we had to refactor things for load and scalability and all that. I'm going to put that right in the prompt to begin with. So all of that experience and everything still is going to be very important, even working with the tools like this.
Yeah, I'm gonna interject just one more thing. Is that the in that question, you might want to like search for OpenAI, and then the I think it's what they their paper release is called the Sui Lens, and then the it was saying that the all these coding agents, they were solving maybe about like a 20% of solutions. So it goes into the David's point that the expertise still matters.
And I think, not mistaken, yeah, Thomas references, I think, that paper in, here we go, Project Padawan. Yeah, Sui agents introduced in this paper. Not sure if this is the paper you're referring to.
Yeah, I think that's actually a little older one. The Sui Lens, I think it came out like maybe a couple weeks ago.
Okay.
So, but there are multiple studies.
Yeah. Yep.
Anyway, next question.
Okay.
Hi there. Well, first of all, I'm pretty sure I'm going to be replaced by an agent pretty soon. But so I've been using Copilot a lot, and it's awesome. And I've used the agent mode, and that's fantastic. It does unit testing, which is super cool too. I don't know if that mentioned that. But one question I had was if you know how the different models are implemented, because I've noticed that, for example, O3 Mini on the ChatGPT website is a fantastic model for coding. But in Copilot, it does not integrate nearly as well as Sonnet, for example, as far as interacting with your code, making edits. Do you know why that is, and or what what you guys do to kind of integrate these different APIs?
To be honest, that's getting into a deeper level of detail than I can address. But what I would suggest, and I think actually I have the link. Whoops. Yeah, I think I have the link in here on the resources page where you can go and provide feedback, ask questions. Yeah, GitHub Copilot discussions right there. I wouldn't be surprised if there isn't somebody already asking questions like that out here. So that would be where to go to plug in to the discussion loop on that.
Cool. Okay, second question.
Hey, how does Copilot compete with like Cursor? Because I've been using a lot of Cursor and I see a lot of the overlap in the features, especially like being able to process images, generate code, profiling code. So does Copilot team also monitor what Cursor is doing? Is it like a competitor, or like if I have a Cursor, should I consider Copilot? How does it work out?
So I don't know a lot about Cursor, to be honest, but when you look at Copilot, it's not just in the editor. You've got Copilot chat right on github.com itself. So things like workspaces and things like that, you're on githubcopilot.com. You're not in Visual Studio or JetBrains IDEs or something like that. We're also and this is live now. If you're working with GitHub Advanced Security and you get security vulnerabilities, there's a substantial number of those security vulnerabilities now. You go into the security alert and it'll say, hey, do you want Copilot to generate an auto fix for you? So now that's extended into, so it will give you a code diff there and say, here's how we think you should fix this code. So tying it in with GitHub Advanced Security, being able to work through errors that come up in GitHub Actions workflows and things like that. So GitHub Copilot's becoming ubiquitous throughout the platform. And then I also touched on things, and it's going beyond that too, right? With the GitHub Copilot extensions. Now I can plug into my other tools and that through the same interface and things like that. So, that's where GitHub Copilot just continues to grow in breadth and its capabilities and everything.
Just to follow up. So with this interfacing with agent workflows, there is a lot of code that's like getting automatically generated, right? So in my experience too, when I'm like working with this, I run into a loop where, it's working, make it better. And then suddenly it breaks, right? And now I want to like go back to like some other previous checkpoint or something. So I'm used to version control on Git, like when I'm doing it on my own, but with this automated thing, when it moves so much faster, is there like a different kind of a version control or something that that could come in handy to like mitigate some of those issues?
Okay. Yeah. So this is all still very, very new, but I've seen some talks and discussions and things about kind of, putting checkpoints in there, say, okay, yes, I want the agent to do the work. The agent does the initial work. Okay, that looks good. Let me put a checkpoint in there and then move on to the next phase and things like that. So that I can be able to roll back and things like that. But this is all very new. So we're even learning from, as you and everybody else is playing around with it. Yeah, it's important to go back to those discussions and say, hey, yeah, I've got this scenario where, this happens and I want 80% of what it generated, but I need to, go and refactor this 20% or whatever. Well, okay, what would be a good, just logical workflow to do that kind of a thing? That probably something that we'd still have to work through, kind of a thing. So yeah, it's very much evolving, but I think we're thinking about the right things. Does it sound like it? Okay.
One of the things I was surprised at in one of the demo videos was that it was able to pick up that there was a non-existent table and suggest another table instead. So how would that be implemented that the Copilot knows that a table doesn't exist?
I think in that case, if I know what section you're talking about, I don't remember if it was saying if it brought in at workspace. So it was looking at the entire Visual Studio Code workspace for context. So within that workspace was the references to the tables and things that it knew about, and recognized that, oh yeah, that doesn't exist in this table. So, and there was a reference when I was talking about the JetBrains stuff. In JetBrains, that's at project instead of at workspace, bringing those kind of capabilities there too. So.
Okay. Any other questions? All right, one more.
Just sort of a follow up on the gentleman in the back is talking about his experience with Cursor, and we're finding that we're generating many times lines of code a day. So it's not like just a 20% or 30% improvement, but a 10x improvement. And so it changes your entire workflow. So it used to be like you do a check-in of 10 files or so addressing a particular issue in Jira, and now you're checking in 100+ files with reams of comments about like what you've done, and that's a day's worth of work, and that's not that unusual. So I'm hoping that you guys are really thinking the entire process. It is a runtime process. It's not like you want to roll back by the hour. You don't want to like roll back from 3 days ago. And so it's almost like it has to be like auto check into GitHub constantly so that you can do those kinds of rollbacks and what ifs and things like that you couldn't do before. So my communication back to you is just really rethink the entire software engineering process.
Well, and I think even going from back in the day, I've been in the ALM DevOps space for a long time, right? And one of the things about good practices with that was leveraging Git-based source control versus TFVC or SourceSafe or something like that, because that encouraged you to do smaller chunks so that it was just because of the nature of the branching and things like that, so that you could manage things rather than having a week's worth of changes back in the day because things were so manual and stuff. But yeah, I see what you're saying. Now that we've got all these automated tools pumping out stuff so fast, yeah, what does that mean for, oh, hey, I've got a day's worth of work here. Now I found a problem and I need to kind of roll back, but I haven't checked in. So
conflicts because suddenly now you're moving at a much faster pace. How do you resolve all those things with all the different branches that you're checking in, and then you're trying to reconcile all of that?
Yeah, there's definitely a lot of work to be done there. One of the things that comes to mind is, we saw Copilot actually performing some of the code reviews, so that can help speed up some of that process. I'm not saying that's by any means the only answer, but something to help.
Okay, thank you, David. And we still got a little bit of time, so you're going to be staying after, and then if there's any in-depth question,
I can hang out for a little while.
That'd be great. So before we adjourn,